Welcome to the third video for binomial theorem. In this video, we will take a closer look at a plus b to the power of n, and we'll look at the general term. Now previously we have seen the sixth expansion here using the Pascal triangle, and if we change the value of 1 to the value of a, these are the terms that we will get if we expand them manually. Do you realize the pattern again? Yes, you realize that the coefficients remains the same. The only difference is you have inserted some values of a here. So what it means is, in this case here we have 1, 3, 3, 1. Here we also have 1, 3, 3, 1. But we also see that we have a cube, a square, and a. For the power of 4, we have a power 4, a power 3, a power 2, a power 1. Now, do you realize that for the first term, the power is decreasing? For the second term, the power is increasing. And very important observation is the power of the two terms will always add up to 4 in this case. And the power here will add up to 5 if we are expanding to the power of 5. So 3 plus 2 will give us 5. 2 plus 3 will also give us 5. 1 plus 4 will also give us 5. And every term here, the powers will add up to 5. And seeing these patterns, we come up with the formula for the binomial theorem. For the first term, the power will be decreasing by 1. For the second term, the power will be increasing by 1. And if you add up the powers, it will be always the same as the power here, in this case, n. Don't worry, we will take a closer look at this formula again using some examples later. But first, you see that in the formula given, there is this important term here. Now, this term is called the general term. So, this term will be the r plus 1 term. Now, what's the meaning of r plus 1 term? So, let us look at this example. So, this will be the first term. This will be the second term, third term, fourth term, fifth term, and sixth term. Now, do you realize that the term is actually 1 more than this number here? The term is actually 1 more than this power here. So if we look at the power here, this term is not the rth term, but it's actually the r plus 1th term. So again, in this case, this will be the first term. This will be the second term. This will be the third term. The value of r is 2, but the term is actually 2 plus 1. And this is something that is noteworthy, all right, when you are looking at the terms. So the rth plus 1 term is given by this general formula, and choose r, a power n minus r, b power r. What this means is you can actually find any term in the binomial expansion without having to expand every single term. Now, in this next part of the video, we'll just look at using the binomial theorem formula, and we will leave the general term to the next video. In this question, we are asked to find in ascending powers of x just the first 4 terms of this expansion. So, once again, it's good to write down the values of a, b, and n. So, a equals to 1, b equals to negative 2x, and the value of n is equals to 10. So let's simply try to apply the formula here. We will have 1 to the power of 10, which is simply 1. And we will have 10 choose 1. So all this will become 1 here. And then we will have b, which is negative 2x. Followed by 10 choose 2, negative 2x square. Now we ignore the a because a is just the value of 1. So anything multiplied by 1, you can just simply ignore it. And because we need 4 terms, so we have 1, 2, 3, and we need to do it once more. And once again, do realize that the value of r and the power here will always be the same number. So we have, lastly, 10, choose 3, negative 2x, and it's the same number, so we will put 3 here. Now, since the expansion has not ended, you must put these 3 dots after the plus sign towards the end. So, in order to speed up, if we press calculator here, this will actually give us a minus sign. So let's speed this up. So if we use the calculator, this will actually give us minus 20x. And this will give us plus 180 x squared. And here, in case you forget, we will press 10, choose 3, multiply by negative 2 cube. Please remember to put the brackets. And we will have minus 960 x cubed. Make sure the powers are in increasing order, plus dots, dots, dots. Now what happens if we have this instead? In the binomial expansion formula, we have only a and b. So what do we do here? Well, we can group it this way. The value of a can be equals to 1. Now for the value of b, we can group it as minus x plus 2x squared. And for the value of n here, we have 10. So in this case, we can still apply the binomial expansion formula. All right. So I'll shift this up a bit. Just remember n is 10 so that we can see the formula here. So what we'll get is 1 power 10 plus 10 choose 1 multiplied by the value of a, which is 1. So we just ignore it. And multiply by the value of b, which is negative x plus 2x squared. Next, we will have 10 choose 2, and we will have minus x plus 2x squared square. Because remember, the value of r and this power is actually the same. Now, do we want to continue? We only want the first 4 terms. So the first 4 terms will be the constant, the x term, the x squared term, and the x cubed terms. All right. So we will have to do it once more, one last time. Because this will give us x cubed. And we do not need to continue any further. Now, it may seem very daunting to cube this, but actually you will see later that we actually do not need to cube everything. We just need the first term of this expansion. Because if the first term is already a cube, the second term will be more than the cube, and so we do not need to continue any further, as we just need to stop at cube. So what we'll have here is 1 plus, now it will be good in this case to just write out what is 10 choose 1 first for simplicity later when we do the question. 10 choose 2, we will have 45. 10 choose 3, we will have 120. Okay, let's take note of this first. So what we will get is 10 multiplied by negative x. So we will have minus 10x. Then we will have plus 20x squared. We will have, yes, we need to expand this first, right? So we will get x squared minus 2x cubed. Okay, minus 2x cubed again, so it will be minus 4x cubed. Okay, let's simplify here a bit first. Plus 4x power 4. All right. So now let's expand this. We will have 45x squared and 45 multiplied by 4 is 180. So we have minus 180 x cubed. We are not interested in the power 4 because we only need the first 4 terms, which is the constant, the x term, the x squared term, and the x cubed term. So let's ignore this term. All right. And finally, we have 120 multiplied by negative x cubed. So we'll have minus 120x cubed. And we know that any expansion after the first one will be more than x cubed. So we don't need to expand every single thing. So let's stop here because anything will be more than x cubed after that. So we once again, we're only interested in the constant term, the x squared term, and the x cubed term. And let's simplify by grouping the like terms together. We will have 1, and this is the only x term. We have the x squared terms here, and we have the x cubed terms here. And that will give us the first 4 terms of the expansion. Now, you can try the next question on your own, whereby A is 1, B will be negative 2x minus 4x squared, and the value of n is actually 11. You should be able to get these first 4 terms. Just remember, do not overly expand. You only need to expand up to the constants, the x squared, and the x cubed term. Now, we will look at what happens if the value of A is no longer 1. What happens if it's 2? How do we use the binomial expansion? So we will leave these important parts to the next video.